In this video, we're going to be talking about both writing and naming those chemical formulas that involve our polyatomic ions. So remember, the only difference between a monatomic ion and a polyatomic ion is a polyatomic ion, those like to stick together. So I've given you a common polyatomic ions chart on your Google form. The important thing to notice is, for example, if it says nitrite, which is NO2 minus, it likes to all travel together. So I'll show you an example of what that means. Remember aluminum, if we look, it is in this third row, it'll actually have a charge of 3+. And remember, that's our metals on the left side. So we have Al, 3+. And then sulfate, which you can get from that chart I gave you, is SO4 and then 2-. So, like I said, these like to all travel as a unit. You cannot separate that sulfur from the oxygen. So when we cross over, we're going to take this 3 and cross it over to the sulfate side. Take the 2, cross it to the aluminum side. And what we end up with is Al2 and then SO4, 3. Now we have to remember this 3 applies to this entire unit altogether. So to distinguish that, we put a parentheses around that. So we remember that it's not 43, it's SO4, and there's 3 of them. When we are going to name this, it's very straightforward. We just take aluminum, and we said it was sulfate. It is aluminum sulfate. So it is exactly what you saw written at the top. Magnesium, so we have a magnesium. Remember magnesium, if we look, it's in this second group right here. It likes to have a charge of +2. So we have 2+. And then we have nitrate. Again, if you look at the list, it is NO3 with an overall charge of -1. Remember, if it's a 1, we just put that negative sign. So we will take that 2, cross it over to the nitrate side, and then from the left, to go to the left-hand side, we just take a 1. Remember, we're not worried about positive or negatives. So what we end up with is Mg, and then we have NO3, and we brought that 2 from the left when we crossed over those charges, and we get the 2. And remember, to distinguish that this whole thing travels as a unit, this whole polyatomic ion, we draw our parentheses. Now, if the charge, for example, was a number 1 and this was also a number 1, you wouldn't have to worry about drawing the parentheses, but we just do that to distinguish when there is a number right here, so we don't get confused. It's not 32, it's NO3, and there's 2 of them. And again, this is just called magnesium nitrate. So if you ever, for example, just see MgNO3 2, you could just reverse that, cross over backwards. That 2 goes to Mg, and the 1 goes to NO3. And you know the NO3 minus is nitrate, so that tells you that it's magnesium nitrate.